Hi, this video is on piecewise functions. And so unless you've had this class before, this is probably the first time that you're seeing piecewise functions. And they are what they sound like. They are functions that are divided up into pieces. And how you decide what piece goes where is by the domain, where it's defined. And so behind me I have a few, and on your worksheet you see a few examples of a piecewise function. Now we are learning this is an introduction to us, so our piecewise functions are only going to come in 2 or 3 pieces. We're not going to look at too many. However, some functions exist that are in an infinite amount of pieces, and so there are some examples in real life about that. But we're just getting introduced to this, so let's look at what this means. So this one, f of x, is a function, and what this means is that for values of x that are less than -2, our function is defined to be -3. For values of x that are between -2 and 1, and even equal to -2 and equal to 1, our function is defined to be 1. And for values of x that are greater than 1 to the right of 1, our function is defined to be 5. So this is what that looks like. If I'm going to make my axis in green because that's easy. It's a light color and it's easy to erase. So here is our XY axis. So what we're asked to do for these first problems are simply to graph it. So I've provided some graph paper that you can download and print out, or you can just bring your own graph paper. There's nothing special. Just draw yourself a little XY, but it's good to use graph paper when you're learning how to graph these so you get things in the right places. I don't have graph paper, but I would be using it if I was doing this at home on a piece of paper. So this is X and this is Y. Okay. So this is the function we need to graph. So we take note of how our x-axis is being divided. So here we have -2, -1, 0, 1, 2, 3, 4, 1, 2, 3, 4, and so on. Here's -3. Okay, all right. So what this says is for values of x to the left of -3, this is our function f of x is equal to -3 for that part. So I'm going to use different colors. I'm going to use green for the top part. I'm going to use blue for the middle part. For the middle part, when f of x is, when this is where our x is, f of x is equal to 1. And down here, when x is greater than 1, f of x is defined to be 5. Okay. So our function is defined differently in 3 different parts. Okay, so for values of x that are to the left, less than -2, to the left of -2, f of x is -3. If you recall our discussion of lines, y equals to a number is just a horizontal line. This graph is just going to be a flat line, but where? At y is -3. So we'll go down to -3 and put that on there. -1, -2, -3. So down here is where it is. Where? For values that are to the left of -2. So here's -2, right? We go down here, and to the left of -2 is where it's going to be this horizontal line right here, in line with -3, with y is -3 right there. Okay, that's what that part of the graph looks like. But then, when at -2, because it's or equal, and all the way up till where x is equal to 1, it's different. It's equal to y is 1. That's another horizontal line at y is 1. So let's go up to where y is 1. And at -2, let's go up here to where y is 1. Let me mark that. Let me give myself 1, 2, 3, 4, 3, 2, 1. At 1, okay. That is where it's equal. So at -2, we go up here, solid circle. All the way to 1, solid circle. This is what our function looks like between here and here. But then as soon as it gets to the right of 1, greater than 1, it jumps up to 5. So we got to go all the way up to 5. Let's put that piece on there. This is 5. All right, so we go up here. And if for all the values that are greater than 1, this is what our piecewise function looks like. And so that's a good one to start with because horizontal lines are real easy to graph, and that kind of illustrates what's happening. The solid dots right there go in line with where this or equal to is. What splits up our function? Where we are on the x-axis. That's what splits up our function. That's important to kind of get in your head. Okay, let's try g of x. No. We'll come back to g of x. Let's try m of x. I think that's the next one we should do. So let's draw on here. Here's our little xy axis. All right, so this one is not in 3 pieces, it's only in 2 pieces. So this is x and this is y. Okay, and our y this time is m of x, okay? This is the absolute value function, and we know that that is a v shape and that the slope is at 1 and -1. But where is this? So sometimes I think that I'm going to do it a little bit differently than this one because horizontal lines are so easy to graph. I could just put it up there. This time, what will I do? I will just maybe look at this part of the graph and say, what is this function? This is y equals to the absolute value of x, and I will just graph the whole thing on there as if it belonged everywhere. So just like this. I'd give it a slope of 1, I'd give it a slope of -1, and I would draw the absolute value of x. And then I might say, wait a second, this is piecewise, where does he belong? This absolute value graph, I'm going to do him in green. He only belongs for values of x that are to the right of 0 and equal to 0. Well, this is where it's 0, and this is where it's the right of 0, right? 1, 2. So it's a closed circle there. I'm just emphasizing that. And this I'm going to erase off because it is not defined to the left of 0. It doesn't have any business being there. What goes to the left of 0? Well, whatever this is. Oh, this is m of x equals to -2. All right? This is m of x equals to -2. That's what it's defined at for values of x that are to the left of 0. Well, let's put that on there. That's a horizontal line, right? Y equals just to a number. So this is -1 and this is -2. And so it's down here at the value 0. It's not defined. So put an open circle, but everywhere to the left it is defined. So open circle to the left. That is what this one looks like. Now let's tackle g of x. Because it has some other slopes in it. So this is g of x right here. Let's draw ourselves a little xy. All right. For values of x that are to the right of 2. Let's see. I'll do this one in blue. For this one, it says that y equals to x plus 2. All right. And for values of x that are less than 2, this one says that y equals to -x plus 1. Well, let's see. Let's look at this. This is a line. Y equals mx plus b. What is the slope of this line? Well, since it's in slope-intercept form, the slope is whatever's next to the x. So the slope of this blue line is 1/1. And the y-intercept is the point 0, 2. All right. That's this part. Let's just go ahead and graph him on there. Let's see. We learned how to graph lines in the last video, so you guys know how to do this. Let's find our y-intercept. I'm going to go up to 2, and I'm going to put a point. I'm going to interpret my slope. I'm going to go up 1, right 1. And I'm going to draw my line. Draw your line, just like that. This is that part, that piece of the piecewise function. Now, let's make a good decision. Where does he belong? This line right here only belongs for values of x that are to the right of 2. That means to the right side of 2. So that means if this is 1 and this is 2, 1, 2, we go up here to where it hits this line, okay? And what we want to keep everything to the right side of this line, and everything on the left side that I needed to graph that does not belong there, because it is not defined there, so I just erase that part off. If I were learning how to do piecewise function and I was not using a whiteboard, but I was at home with a pencil and paper, I would still draw the whole line and I would flip my pencil upside down and erase it with my eraser, because that's a good way to learn this. Why did I leave that as an open circle? Because of this, no or equal to sign. Now let's look at the red line. What is the red line? Okay, what's his slope? -1/1, because it's in slope-intercept form. What is his y-intercept? 0, 1. So let's graph him, see what he looks like. Okay, we're going to go up to 1 and put a point. We're going to interpret the slope, down 1, right 1, and we're going to draw this line. So I'm just going to draw the whole line on there, just like this. That is that line. Now I'm going to make a good decision about where he belongs, because right now, this is not a function. Do you see it does not pass the vertical line test. So let's make sure that we know that. Where does this belong for values of x that are less than or equal to 2? To the left of 2 and equal at 2. So at 2, I'll go down here and I'll say, okay, I'm going to make that a solid circle because where it equals to, it's defined, and then keep everything to the left. So that is what that function is going to look like. That's the graph of this piecewise function. Okay, let me see. Let's go on. Let's go ahead and finish this. I think we can do it in this one video. So let's get the next ones on here. I kind of explained what it was. Number 4 is, let me get this on here. Okay, number 4 is this. H of x is equal to the square root of x for values of x. This is number 4. H of x is equal to the square root of x for values of x that are greater than or equal to 0 is equal to negative x plus 1 for values of x that are less than 0. Number 5, we have this j of x is defined to be the square root of x minus 2, negative 1, x is greater than or equal to 2, x is less than or equal to 0. Number 6, k of x is equal to negative 1/3 x plus 2, x minus 5, x is less than or equal to 1, x is greater than 1. Okay, let's graph these guys. Number 1, h of x, let's get him on a graph. Here's your xy. Okay, the square root of x, that's one of our basic graphs. We know what it looks like. You can plug in points to get a graph of this, but we know, let's just go ahead and graph him. I'm going to graph him in blue, the top part in blue. So I'll do this. And so here, it's defined at 0, and then it goes like this. And you say, well, where does this guy belong? Well, this is where he belongs, to the right of 0 and equal at 0. So that's what he looks like. We didn't have to change anything from what the natural graph looked like. Well, what's happening to the left of this? Oh, to the left of this, we have this line. Okay, let's do that one in red. Y equals to negative x plus 1. This is the slope here is negative 1 over 1, and it's got a y-intercept of 1. Let's graph that line. How I graph it is I put a y, I go to the y-intercept, I interpret it. I'm going to go this time, I'm going to go up 1, left 1, up 1, left 1. You could also go down 1, right 1, but I kind of didn't want to mix up with the blue. And then I graph my line. Okay, I'm going to graph my line. Oops, I'm going to graph my line. And it would keep going, but can I already see that the blue's where it belongs? Woo, let me do a little bit better job there. That doesn't look so good. Okay, let's try that better. Straight edges help a lot. Okay, there's my line. Okay, so I would continue down, and if I needed to, I would, and then I just erase it off. At 0, it's not or equal to, so I need an open circle there. And this is what this piece function looks like when you graph it. Okay, piecewise function looks like. Okay, how about j of x? Let's graph him. J of x, here's my little xy for him, okay? For values of x that are greater than or equal to 2, it's this. Okay, first let's just graph this guy. This is the square root function like that, but something's happening to it. It's got a horizontal transition, and I recognize that as being horizontal because it's inside messing with the function. And so that we know is opposite of what it appears to be, so we're going to go to the right 2 and start to graph our function. This is the basic graph. We're just going to move to the right 2 units. 1, unit 2, unit, and then I'm going to graph, whoops, I'm going to graph my function just like that. So that takes care of that. Now you say, well, where does he belong? Well, this belongs for values of x that are greater than or equal to 2. This is 1, this is 2, this is greater than or equal to 2. So it just stays just like that, okay? Let's graph this guy. This is the function j of x equals to negative 1, or y equals to negative 1, or a horizontal line right there at negative 1. So let's go down to negative 1 right here. Negative 1, and so it's this horizontal line. Let's graph it in red. So it's this horizontal line right here. Right here's where it is. Okay, where does it belong? It belongs for values of x that are to the left of or equal to 0. Where's 0? Right here. Where's left of 0? Right here. What about this part? You erase it. it doesn't have any business being there. So what you're seeing here is a function. This is the correct graph of this function. But you see how it's got this space in here where there's no picture, there's no graph? It's undefined. This function is undefined between values of 0 and 2, and sometimes that happens. Okay, great. Let's do k of x. Let's graph this guy. Here's my little xy. The top piece, I'm just going to say this is k of x or y. This top piece right here is y equals to negative 1/3 x plus 2. Okay. In the bottom piece here, I'm going to look at this and say, okay, this is y equals to x minus 5. I'm just going to graph this on here. This is a line. His slope is, what is the slope? This is in y equals mx plus b, so the slope is negative 1/3. And the y-intercept is 2, okay? Look at the red line. That is also a line, y equals mx plus b. The slope is 1. The y-intercept is negative 5. Okay, these are the two pieces. Let's graph this line. Go up to 2, and then interpret your slope. So let's see. Let me give myself some little marks here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3, 4. Okay, I'm going to go up to 2. Up to 2. Interpret my slope. It's negative 1/3. I'm going to go down 1 and write 1, 2, 3. And that gives me 2 points, and I can graph my line. So here is my line right here. Just like that. Okay, cool. Now I say, where do you belong? Where do you belong? You belong for values of x that are less than or equal to 1. All right. To the left of or equal to 1. So go up here to where it equals 1, right here, and mark that. And we're going to keep everything to the left side. This is kind of like a dividing line. Some people like to dash that. Okay, this is a dividing line. Then get rid of everything on that side of it because it has no business being there. It's not defined there. What is defined to the right side of 1? Well, this other line, this red line. So let's graph him. Let me put some little marks on here. Okay. This is this line. So go down to negative 5. That's the y-intercept. So I did not, that's negative 3, negative 4, negative 5, negative 6. Go down to negative 5, negative 1, 2, 3, 4, 5. Okay, then interpret your slope. I'm going to go up 1, right 1. I'm going to go up 1, right 1. Okay, so let's see. I was supposed to be doing this one in red. Here we are. Negative 5, up 1, right 1. Draw your line. See what I did with my straight edge? Oh, no. Where's my straight edge? Oh, my dog's sitting on it. Sorry. Sorry, Henry. Here we go. So right here, this is what this looks like. Right there, okay. Now, where do you belong? You belong for values of x to the right of 1. Not even equal 1, but to the right of 1. So at 1, you get an open circle, and you keep everything to the right, and you erase everything to the left because it doesn't belong there. And that is what that graph looks like. The last thing you have to know of what to do with piecewise functions is interpret it, like evaluate it for different values of x. So, number 7, I put that on there. Here it is. We have to evaluate, this is 7, evaluate these functions. And here is the graph. N of x is equal to x to the 3rd minus 2 for x is less than or equal to negative 1. The absolute value of x for negative 1 is less than x is less than 1/2. And negative x plus 1 for x is greater than or equal to 2. Okay, we don't have to graph this, but we do have to interpret it for different values of x. So, what values did they ask us to do? They gave us a bunch. I say they, it was really me. But here, we had to say this. What is n of negative 2? N of 1, n of 2, n of 3, n of negative 4, n of 0. This is what we had to decide. This is where I really want you to understand. This negative 2 is an x value, and it only belongs one place. It does not belong 3 places or even 2 places. It only has one place it belongs, and you have to find the right place to put it. Same with 1, 2, 3, negative 4, 0, because this is a function. There's only one place that you plug it into. So we have to decide, does it belong in the top, the middle, or the bottom piece of this particular function? So x is negative 2. Does negative 2 fit in the category of less than or equal to negative 1, the top, between negative 1 and 1/2, or greater than 2? It belongs in the top piece. Now, if you have trouble kind of seeing this, it is very helpful to draw yourself a number line. So if you draw yourself a number line, here's 0. And so we say, oh, where is this function kind of being split? At negative 1, okay, and then at 2. Okay. So if you draw yourself a number, you're like, well, where is negative 2? Negative 2 is on this side of negative 1. It's to the left of negative 1. You can see that it belongs in the top piece, so only put it in the top piece. It belongs in the top. So this is going to equal to negative 2 cubed minus 2, which is going to give you negative 8 minus 2, which is going to give you negative 10. That is n of negative 2 equals to negative 10. This is 1 point on my piecewise function. How about n of 1? Where does 1 belong? Okay. 1 is it less than negative 1? No, it's over here. Is it between negative 1 and 1/2? Let's see. This is negative 1, and this is 1/2, right? And this is 1. No, it is not between negative 1 and 1/2. Okay, is it to the right of 2? Here's 2. Is it to the right of 2 on this side? No. 1 is in this right here, this region right here, and we don't have any function that's defined there. See, between 1/2 and 2, this is kind of an undefined region right here. So the answer here is undefined. Sometimes that will happen. In fact, this picture right here, it happened right here. It was undefined in that little region. What about n is 2? Oh, here, it's equals 2. It goes in this piece. This is the bottom piece. Negative 2 plus 1, negative 2 plus 1, negative 1. So this means when x is 2, y is negative 1. All right, 3. Top, middle, bottom. 3 is greater than 2, bottom. So this is going to be negative 3 plus 1, negative 2. This is the point 3, negative 2 if you were graphing it. X is negative 4. Top, middle, bottom. Negative 4 is to the left of negative 1. It goes on the top. So this is going to be negative 4 to the third power minus 2. That's negative 64 minus 2, or negative 66. When x is negative 4, y is negative 66. N of 0. Where does 0 belong? Is 0 to the left of negative 1? No. Is 0 between negative 1 and 1/2? Yes, it goes in the middle. So we're going to say this is equal to the absolute value of 0. Ask yourself, how far is 0 from 0? It is 0 units. This is another point. So the last thing you have to do is evaluate a function for different little x values.